Hello, Trig students. Mr. Meunier back here again today. We're going to continue our look at applications of circular trig functions, basically big story problems for our sine and cosine graphs. Today, I want to talk about this water wheel problem that tends to give people a little bit of trouble. And I also want to make sure doing this that I can kind of do an in-person and a video for every part of every class. So, looking at problem one, and this is off of your worksheet, which is within this folder. It was also the worksheet given to you last class period. I asked you to do number 3 on this worksheet for today. 3 is the problem that deals with the foxes. That kind of mirrored the Tarzan example. You either watch the video for or you listen to me teach you last class period. Today, we're going to talk about this water wheel problem. With this problem, says suppose that the water wheel in the picture rotates at 6 RPMs. 6 RPMs. You start a stopwatch, and 2 seconds later, the point P on the rim of the wheel is at its greatest height. So there's a point somewhere, somewhere on this wheel, we'll say right there, is point P. That spot is rotating around the wheel. As the wheel spins, that point moves. 2 seconds after you start the stopwatch, that point will be at the top. So after 2 seconds, we're at the maximum height. Assume that P's distance above the water is a periodic function. So again, periodic means it's regularly repeating. It's repeating on consistent intervals and depends on the number of seconds T since starting the watch. Sketch the graph and write the function. So kind of like last time, part A and B go together. We want a graph of it and an equation. From there, you're going to use your graph and equation to answer follow-up questions about specific times or moments. Not a lot of info here, but we have more than enough. We know what's going on. We know from this picture, you have a water wheel that's 6 feet. The center of it is 6 feet above the water. The radius on this wheel is 7 feet. So if 6 feet's the middle here, that means this maximum is 6 plus the 7, taking us to 13. And that's going to happen at 2 seconds. So at t equals 2, we have a d equal to 13. That's our max. We also know 7 is the radius. So if 6 is the middle and I move 7 meters or feet, what is this one in? Feet. 7 feet down, we're going to have a negative 1. So d equals negative 1 is our minimum value. Now, when that happens, might be a little bit tougher to see. And that's what 6 RPMs is helping us with. 6 revolutions per minute. A lot of times people tell me the period, the amount of time necessary to repeat is 6. It's not true here. Again, remember your period is how much time you need to go all the way around. If we do 6 revolutions in a minute, that means we're doing 6 revolutions every 60 seconds. 1 revolution then will be 10 seconds. 1 revolution will be 10 seconds. 6 times in a minute means 1 time in 10 seconds. So our period is 10 seconds, is 10. And we can use that to figure out when this minimum is going to happen. If it takes 10 seconds to go all the way around, 10 seconds all the way around, that means it's going to take 5 seconds to go halfway around. 5 seconds to get halfway around this. So if 2 seconds is the top, halfway around the bottom is going to happen at 7 seconds. So t equals 2 means we have a maximum value of 13. T equals 7 means we have a minimum value of -1. The period is 10 seconds. We can use that period equal to 10 to figure out the W value. 10 equals 2 pi over W. 10W equals 2 pi. Divide, and W is going to give us pi over 5. So now I know my W value. The vertical shift, the H value, is always the middle of that y-axis. Well, the height, the middle of this wheel is at 6. 6 feet is representing the midpoint of our wheel. 6. Amplitude is how much you stretch above or below the middle. Well, that's the radius of this problem. We're moving 7 feet up and 7 feet down. That's an amplitude of 7. Height 6, amplitude 7. Period is 10 seconds. W value is pi over 5. I'm going to go to a different picture to kind of map all this out for us. Let's get rid of this. So, picture-wise, at t equals 2, we just said there is a maximum value of 13. We also said at t equals 7, there's going to be a minimum value of -1. Period of 10 seconds means 10 seconds to repeat. So 2 seconds is a max. 10 seconds later will be another max of 12. 10 seconds after your minimum takes you to 17 seconds. That's going to give us a minimum value of -1. I've discussed before on these particular types of problems, I don't need key points. I want you to use maxes and mins, put at least a period through this. Really just put as much as you need to answer the questions in front of you. So we got something that kind of looks like this right now. We've said the middle of the y-axis is at 6. Amplitude is 7 units up, 7 units down. Phase shift on this problem. I'm going to rewrite those values. H is 6, amplitude is 7, period equals 10. From that, W is pi over 5. Phase shift. I recommend you use the first max value. First time we're at a maximum is 2 seconds into this problem. If I use the first max, that makes it a cosine problem. So your default setup is y equals h plus a sine or cosine w t minus d. This particular problem was using a d-axis for distance and a t-axis for time. If you don't do that, I'm not going to count you off, but it is nice to be consistent with what the problem's asking for. So here we have d is height 6 plus amplitude 7, cosine, because I'm using the maximum value to get this thing rolling, w value of pi over 5, t minus 2. So again, that is a function. This is a nice picture to get us going, part A and B. Part C was asking specifically when time is 7.7, what is the height of that point P? So all we got to do here is say T equals 7.7, find the D, find the distance from the water level. So use your calculator. Distance is going to be 6 plus 7. Cosine pi over 5, 7.7 minus 2. Take a moment, plug that in, make sure things are working, make sure you're in radian mode. Your calculator must be in radian mode for this. You should get about negative 0.3 feet on that. And if you're not, you need to talk to me, figure out what's going on. And that does make sense. If I look 7.7, it's a little bit after 7. I can definitely see that being a negative number. Okay. Part D, find the first and second time at the point P emerged from the water. So emerged from the water. If we look at this blue curve is kind of modeling where that point's at. Positive number is above water, negative number is in the water. We want to know, when did it come out of the water? So probably right in here, maybe right in here. Well, that's going in, sorry. You erase that. Whoops. So probably, like I said, this orange dot I put and the second orange dot just after 17. That's probably what we need to figure out. Because again, this, where my pointer is now in front of 7, that's going into the water after 7's coming out of the water. In front of 17 is going into the water. After that is coming out of the water. And to make that happen, I need to know the water level. That would be 0. D equals 0 is the water level. I want to figure out what the time is going to be. So part D here, we need D equal to 0. Find the time. 0 equals 6 plus 7 cosine pi over 5 t minus 2. Work this out carefully. Subtract the 6 over. Negative 6 equals 7 cosine pi over 5 times t minus 2. Divide the 7. Negative 6/7 is the cosine of pi over 5 times t minus 2. Move cosine by doing the inverse of that. That is the cosine -1 button on your calculator. We haven't really discussed much yet. We will in chapter 7. So you have inverse cosine of negative 6/7 equals pi over 5t minus 2. Multiply by 5, divide by pi. 5 over pi times inverse cosine of negative 6/7 equals t minus 2. And finally, add that 2 over. 2 plus 5 over pi times inverse cosine of negative 6/7 equals t. I would take your time in the calculator. Inspires, you can enter that in quickly. Scientifics, I would probably do negative 6/7 inverse cosine of that answer times 5, divide by pi, add 2, one at a time. And as you do that, your calculator will probably tell you 6.1 equals t. And that's where you have to be aware of what was presented to you. 6.1 is right where I'm putting this green dot on the curve. It's in front of the 7. That is not emerging from the water. That's going into the water. And we got that because according to your calculator, 2 is the start. The phase shift we picked of 2 is where things begin. The first time after 2 is 6.1. It's up to us to use symmetry to get the other values. That's 6.1. And I know 6.1 to 7, that gap is 0.9. And since this is symmetric, 7 to the other one, this orange dot, is also going to be 0.9. 7 plus 0.9 means we have 17.9. Or excuse me, not 17, 7.9. So the first time you come out of the water is going to be 7.9 seconds. I double checked that. Here, 2 to 6.1 as a gap of 4.1. If I go 4.1 in reverse, that's a negative number. We don't need to worry about that. So 7.9 is what we're looking for. I could use symmetry to build my way around, or no, every 10 seconds you repeat what you've done. So 7.9 plus 10 seconds gets you to 17.9. So we'll say 7.9 and 17.9 are first two times we emerge from the water. And that's 7.9 and 17.9 seconds. So that's part D. And finally, part E, to end this, asks specifically, find the first time that the point P goes into the water. We've already done that. First time you go in the water is right here at 6.1 seconds. And that's where understanding what the graph you made is revealing is important. 6.1 goes in the water, 7.9 is coming out. We have to use symmetry around the high and low points to find other answers. That and period length. How long does it take to repeat itself? All right, guys, get that copy down. Work on problem 2, 4, and 5 from this worksheet as well. When all this is done, you should have 1, 2, 3, 4, and 5 done for next class. 1, 2, 3, 4, and 5. Hope you guys are doing good. Later.